Well, hi everyone, and welcome to week 3 of transitioning from ROBOTC to VEX Coding Studio. My name is Jesse Flatt, and I'm from the Carnegie Mellon Robotics Academy. This week, we are going to look at more VEX C++ code and how ROBOTC translates over to that. We're going to take a look at a sensor, the bumper switch. We're going to take a look at displaying text to the screen, and we're going to take a look at some remote control code. Similar to last week, we are going to look at how those things were done in RobotC and then how to accomplish them now in VEX Coding Studio. Just a friendly reminder that a lot of these materials you can find on the VEX website in the STEM Labs section. There's a lot of helpful guides inside of there, along with text descriptions that offer some really great supports. So if you're still looking for more in-depth explanations after these webinars, feel free to check that out. Also, feel free to check out the website because it has a ton of great stuff on it, honestly. So first, we'll take a look at forward until bumper press. And so we're using the bumper switch here. Up at the top is the task main program for Robot C. We have a 2-second delay using the wait 1 msec command. And then we have a while loop. And the while loop's job is to check the status of the touch sensor or of the bumper switch. How it does that, how inside of Robot C you were able to check the value of a sensor was using the sensor value command. And then you specified the name of that sensor in between the parentheses. Inside of Robot C, when you use the sensor value command with a touch sensor, like the bumper switch, it would return a value of 1 when pressed or 0 when released. So that's why inside of the while loop up top, we check if it's equal to 0. We're basically asking, are you not pressed or are you released? And then while the sensor is released, it drives both motors forward using the motor commands. Well, this translates over very nicely to VEX Coding Studio. VCS, VEX C++ is the program in the bottom half of the slide. Again, instead of task main, we have int main. That's standard for C++. Instead of the wait 1 msec command, we have task : sleep. But it also allows you to hold the robot's program flow, to hold the program execution at that spot in the program for the specified number of milliseconds. So that line there is going to do pretty much exactly the same thing as the wait 1 msec command. We also have a while loop. While loops are standard in C and C++, so the structure of those, how they work, how they affect program flow, completely the same. The condition is a little bit different. Instead of sensor value and then the name of the sensor, we actually say the name of the sensor first. So here, next to the number 3, we have touch sensor. That isn't a reserved word inside of VEX Coding Studio. That is the name that the bumper switch was given. That is the name that the touch sensor was given on the robot config screen. All right, so whatever name you use on that screen, that's what you'll want to use as part of your command. Then we have a dot, and then the keyword is pressing. Okay, so pressing returns true, or it will have a value of true if the touch sensor is pressed in, or it will have a value of false while it is not pressed in. Our condition here is checking if the value of the touch sensor is pressed in, or sorry, is not pressed in, is released by checking if it's equal to false. And then while it is not pressed in, it is running both of those motors. In the case of both of the programs, as soon as the sensor is pressed in, the condition becomes false, the while loop stops repeating, the program ends, and the motors stop. All right, so very similar going from Robot C to VEX C++ here. Um, There are shorter ways that you could write the condition of the while loop. You could say while uh, exclamation point touch sensor dot pressing open close parentheses. The exclamation point means not. Okay, so you can say while it's not pressing, um, go ahead and loop that, and that would work just fine. But for the sake of the code here, we did use a condition that included a comparison. All right, so displaying text. Inside of the VEX Cortex system, obviously there was no built-in screen, but you could connect a VEX LCD. Usually you would connect that to UART port 2 on the VEX Cortex. There's UART port 1, UART port 2. Port 2 was default in ROBOTC. That screen was what we called a 2 by 16 character array. Basically, you had 2 rows of 16 characters, and so you could display things like text, like numbers, messages, things to the screen. Some teams would even build uh, small user interfaces using the screen to do things like choose between multiple different autonomous routines. Okay, and so having a screen allows you to do that. I should mention that the LCD also included a 3-button array, so you could choose between different things and work with the screen. So we're not going into that level of depth here. All that we're doing is a very straightforward displaying text or displaying a string to the screen. A string is a string of characters. It's a type of data or a data type even inside of C++ and C, and so that's why you see the word string. But inside of the ROBOTC command, inside of the ROBOTC program, we use display LCD string 0, comma 0, hello world. So the command to display the string was obviously display LCD string. The 0, 0 that you see at the beginning is specifying the position on the screen. So that basically meant start in the very first spot on the very first line. And then hello world, notice it is inside of double quotes. It is what gets displayed starting at that 0, 0 position. Now this program here wouldn't actually run for any significant amount of time, so you would want to do this while you're driving forward or doing some other kind of routine to actually observe the screen. Down below, inside of VEX C++, again, we have int main, and then here we actually have 2 different print commands just to be able to show you both of them. But notice that whenever you want to print, printing is something that belongs to the screen and the screen is something that belongs to the brain. So whenever you use the print commands, the different ones, notice that they both start with brain dot screen dot and then the rest of the command. This is similar to what we've done in the past with the motors and what we've done in the past, just the previous slide actually, with the touch sensor, except that the keyword brain is given to you. Inside of VEX Coding Studio, if we take a look briefly at the robot config screen, and right here I just have a program already open. Every single time that you use the robot config screen, you will have a brain object in there. And that's because anytime you download a VEX Coding Studio program, it's going to download to a V5 brain. So this object, this component is always inside of your program, and it is always named brain. So whereas with the motors, with the touch sensor, you can change those names. With the print commands, since they belong to brain and since that's provided and locked in, it will always begin with that word. All right, so they begin with brain dot screen, and then here we have two different commands, print and print at. So with print, it will start displaying this text here, hello world, wherever the cursor previously left off. So in this case, that's right at the top because there's been nothing else been printed. But in the second line, print at, it does allow you to specify position values. So here it's specifying 1, comma 40, and then allowing you to display hello world again, exclamation point. Notice that here, like inside of ROBOTC, the strings, the text that you specify inside of your program does get encapsulated or put inside of double quotes. Okay, so that's another standard C and C++ thing that completely carries over, which is that strings or text must be specified inside of double quotes. All right, now we got a handful of questions regarding remote control. So hopefully this helps answer that out there. I have a couple of slides, one that shows just remote control, and then one that introduces buttons and mapping buttons to control arms and things like that. So if you're interested in the button part, just hold tight with me. Um, the code here is for tank control. Remote control uh, allows you different methods of controlling your robot. It kind of comes down to driver preference, whether they like something called tank control versus arcade control. With tank control, what we mean by that is that the right joystick on the controller controls the right side of your robot's drivetrain, and the left side of your the left joystick on your controller controls the left side of your robot's drivetrain. With arcade control, instead, what you have is you have one joystick that controls the forward, backward, turning left, and turning right um, of the robot. So when you push forward, the robot goes forward. When you push the joystick to the right, it turns to the right, and so on. So my code is showing tank, but you could take this code and adapt it to be able to create an arcade program, no problem. The other thing that I should mention here is one really nice thing about the V5 is that it does come with a drive program built in. With ROBOTC and the VEX Cortex, your robot could only ever hold one program at a time. Um, and so if you were doing an autonomous program, it would wipe out your driver control. If you were doing driver control, it would wipe out your autonomous program, so on. Well, with VEX Coding Studio, not only can you hold up to 8 programs, but you can also always use this built-in drive program. And so sometimes you don't even have to do programming when you want to do remote control. Programming with remote control using these signals is most helpful if you are wanting to combine remote control with things like sensors. So if you want to use, a potentiometer to control the upper limit of an arm or things like that, or if you are putting remote control inside of a competition template. Uh, but otherwise, if you just want to drive your robot around like a remote control car, you can use that built-in drive program. All right. So with all that said, let's take a look at the actual code. I do have my remote control tank program here. I have a while loop. The condition of my while loop is 1 equals 1. Well, the double equal sign just checks if what is on the right is equal to what's on the left. 1 is equal to 1. It's always equal to 1. So what we've created in the ROBOTC program is called an infinite loop. And so it's going to repeat any commands in between its curly braces forever. All right. The commands that it's repeating are 2 motor commands, where we say motor, left motor equals VEX RT channel 3, and motor, right motor equals VEX channel 2. The motor command allows us to specify a motor and then set it equal to an amount of power. So sometimes we'll just put in the number 63 or 127 or something like that. In this code, we are instead using the VEX command, which goes out and it retrieves the value from the VEX remote transmitter. Okay, so the VEX command grabs the values from the remote control, um, and then we are assigning them equal to the motors. All right. Again, things translate really nicely to VEX Coding Studio and VEX C++. We have int main, we have a while loop. The while loop works the same way. The condition of our while loop here is the keyword true. True is always true. And so this loop will repeat forever. And so like checking 1 equals 1, this is just going to keep on running until we stop the program or the battery dies. It's worth noting that the keyword true would have worked inside of ROBOTC. That's a reserved word in C and C++. And then also this condition of 1 equals 1 would also work in VEX Coding Studio. So if you wanted to, you could use those exact conditions in either of the other programs. All right. And then the commands that we are using to control the motors and set them equal to the values of the joysticks are the spin commands. Notice here that we have right motor.spin and left motor.spin. As with previous programs and as with like the touch sensor, right motor and left motor are the names that were given to the motors in the robot config screen. And then we are able to tell those motors to spin by saying .spin. All right, for direction type, we're saying direction type : forward. But if you are thinking, well, what if I want my robot to drive backwards? Like, what's going on there? Don't get hung up on that detail. I know that can be a little bit confusing. Instead, what to focus on is the next thing, which is how we're accessing the values from the remote control, from the joysticks. So we have controller1.axis2.position and controller1.axis3.position. The .position command allows you to access the values from the controller joystick axes, okay? And those will provide positive numbers and negative numbers. So even though our direction type was set forward, this code will provide positive and negative percentage values to the motors so that we'll be able to drive the robot just like we could inside of the ROBOTC program. Okay, so the .position command allows you to pull the value from the specified axis, that's a joystick axis, from the specified controller. All right, so, and then we are continuously doing that because it is placed inside of a loop. And so just like with the ROBOTC program, we're just constantly setting the values of the motors equal to the values of the joysticks. The syntax is just a little bit different, but the logic is very, very, very similar. All right. I see a couple of good questions coming in from the chat box, and I'll clarify, even though it looks like you figured it out, Gaming Warehouse. I mentioned something about 8 programs being what you can store. To be more precise, more specific, with the V5 robot, it has what are called 8 program slots. So that means you can have 8 unique programs downloaded to your robot brain at a time. But I didn't mean that to say that you can only have 8 inside of VEX Coding Studio. You can store hundreds or thousands, or depending on the size of your hard drive, millions of VEX Coding Studio programs on your computer. It's just you can have 8 of them living on the V5 robot for you to be able to choose from the user interface at any given time. So thanks for asking that question. Hopefully that clears things up. All right. So this slide has just the ROBOTC program because I wasn't able to fit the ROBOTC program and the VEX Coding Studio program. So the VEX Coding Studio program is on the next slide. But this program combines the joystick mapping with ARM control. Okay, so we have task main, we have a while loop, which will allow the program to repeat forever because it has an infinite condition. Next to the number 4 there, I have my motor commands for my drivetrain motors, my chassis motors, and I'm setting those equal to values from the joysticks. All right. And then for numbers 5 through 9, what I have is a set of if-else conditional statements where it's checking if the up button is pressed. If it is, it's going to go ahead and run my ARM motor at power level 50. But if it's not pressed, else, if the down button is pressed, it's going to run my ARM motor at negative 50. Else, meaning the up button and the bottom button aren't pressed, go ahead and stop the motor. All right, so the if-else statements allow me to check the value of a button, and then depending on if the button is pressed, I can provide power to the arm, or if the button isn't pressed, my program flow, my program execution instead goes to the else, where I can either use a follow-up if to check another button, or in the case with the final else, just to stop the motor. All right, so this is typically how you implement arm control, claw control inside of ROBOTC is with a set of if else, if else. Well, I think you'll find again that the logic inside of VEX C++ is refreshingly similar. Again, syntax is a little bit different, the keywords are a little bit different, but the logic translates over perfectly. We have int main as the main structure of our program. We have a while loop that is repeating all of the commands. And we have the infinite loop. The condition is true, so that's going to keep them running forever, which really means until we stop the program or we run out of battery or something like that. Right? Next to lines number 4, the lines next to number 4, we have the joystick mapping is what we usually call those for the tank control, where we are setting the values of the motors equal to the joystick axis position values from the controller. So as you move the controllers up and down, you'll be able to drive the robot, control its speed, control its direction, all those good things. And then identical to what we had inside of ROBOTC, we have a set of if-else, if-else. All right, but the syntax is a little bit different. With my first if statement next to number 5 on this slide, I'm saying if controller1 dot button R1 dot pressing. All right, so you'll remember the dot pressing command because it also existed for a bumper switch, a touch sensor. And so it's the exact same command, but instead of belonging to a touch sensor, we can see that it belongs to a button, specifically button R1. So that's on the right side of your controller, and then it belongs to controller 1. All right, so button R1 is the specific name of a button, but you can decide the name of the controller on the robot config screen. So if it is pressed, if it is pressing, I should say, then arm motor dot spin. Okay, so very similar to the motor command in ROBOTC. We specify which motor. Here it's the arm motor, and then we specify spin. Direction type is set to forward, 50, and then velocity units is percent. Okay, but if that's button R1 isn't pressed, then my program execution will go to the else if on next to number 8 here, and we'll check another button. Else, if controller 1 dot button R2, so if the second button on the right of my controller is pressing, then lower the arm. Arm motor dot direction type colon rev. So I can see that my motor is going to go in reverse. It's going to go down because instead of saying forward, FWD, here, I've specified rev. My motor speed, or the percentage of velocity is 50, and then again, the velocity is in percent. And then I have a final else, which means my up button, or my R1, my down button, my R2, neither one of those are pressed. So go ahead and stop the arm. And then as MOQ Robotics noticed and pointed out, what we can actually do is we can say arm motor dot stop, and we can say break type hold. So not only are we able to say, stop the arm motor from moving, we can say stop the arm motor from moving and continue to draw power to hold it there. All right, so that's pretty powerful because if you build an arm that's a little bit heavy, or even if you're using the new clawbots, the arms can fall once power stops going to them. So if it's important to you to raise the arm and then keep it at that level, setting the break type to hold here will allow you to do that without tons of extra code. All right, a couple questions coming in. Do you have to specify the controller object as controller 1? Does that mean it can support more than one controllers at a time? Good question. So let's actually go to the robot config screen. And on the robot config screen, let's see, you can see that, yep, you can drag more than one in, but it does look like the name is locked in as controller 1 and controller 2. Okay, so some of the other devices, you can click in and you can change it. Inside of VEX Coding Studio, there is support for multiple controllers. I know that a fair number of competition teams actually split the driving across 2 drivers. And so you can specify controller 1 and controller 2, but it does look like you do have to use those names. Okay, and another question from Brian about the code. Could you also use dot spin direction type forward -50? I'm guessing that you're referring to this arm motor dot spin next to the number 8 here. And yeah, you could. So if you uh, kept direction type forward and just said -50, that would also make it go down. In this code, we chose to use the reverse keyword, or the rev keyword, rather than keep forward and do a negative percentage value. But you can do that interchangeably. As far as I know, it doesn't make any difference under the hood. Okay, just a friendly reminder, VEX does have a really good API at help.vexcodingstudio.com. I've gotten a fair number of questions just about what command do I use for, fill in the blank, or For all of the parameters inside of my spin command, what are my options? And for break type, what are my options? Things like that. I'm happy to answer those. But just so you know, they do have this API where you're able to click on the different component that you care about, the different object that you care about, and you can learn about that command. And then you can also find all of the usable parameters and all of the different usable keywords. And that's a really helpful resource. I know that it's been helpful for me as I've been developing code. And then for those out there looking for activities, for looking for curriculum, there is a section on the site with STEM labs. Um, some of these are programming focused, but some are also math focused. Some are science focused or engineering focused, and they provide valuable activities to do with the V5 robots. They have scaffolded instructions, and then the programming ones do go step by step and include all of the prerequisites, and so they're a great way to get some structured practice with programming inside of VEX Coding Studio. All right, and then I want to keep the webinar open for a little while to do some Q&A, but I want to say, thanks again, everyone, for joining me for the webinar. If you are looking for training, check out our website. We will be offering formal training around the V5 in the near future. Okay, from 56E, how do you connect the V5 brain and VCS via Bluetooth? So I will have to look into that. I'm not sure if that's supported yet. If it's supported, I haven't completed that process myself, but I will check into that to see if it is supported, and if it is, I'll follow up with a comment on this YouTube channel. But um, I know that the uh, if you're trying to just connect your remote to your uh, V5 brain over Bluetooth, that is supported. You can just change that inside of settings. But if you're looking to be able to download code from VCS over Bluetooth to the V5 robot, I haven't done that part myself yet either. Okay, and thanks, Griffin, for specifying that you can't do it yet. I wasn't 100% confident, so thanks for backing me up there. Nicole, how would you fit all the functions into the user control part of the competition template? Sure, so let's take a look at that. So inside of VEX Coding Studio, if I choose New, and if instead of choosing a new project, if I go to Example Projects, I can scroll down and I can choose Competition. And I'll choose VEX C++ and Competition Template. All right. Now, the competition template is similar to the competition template for ROBOTC. It has a little bit of code up top. It has a function called void preaton. It has a function called void autonomous, and another function void user control. So what you can do, void preaton, void autonomous, void user control, those are all actually just already functions. So if you're familiar with how to make functions, there's generally two ways, uh, depending on where you want to put your code. The simplest thing to do is to just create your functions and put them in line, put them in the same um, file as the competition template, save your template as a new name, but then put them above, if they are functions for the autonomous routine, put them above the autonomous routine, do, void autonomous routine 1, void autonomous routine 2, etc. If they're ones for user control, do them above user control. You just want to make sure that you are defining them before they get called, and then you should be able to put them all inside of these programs. Okay, request from Gonzalo. Would you make a vision sensor webinar? Sure, yeah. We will take a look at extending this series to do a vision sensor. If there's some demand out there for that, we're happy to do that. The fourth session is planned to be around ROBOTC graphical and ModKit blocks. And by the way, that is in 2 weeks. Next week, there is no webinar. But then we can take a look at scheduling more of these free webinars for the vision sensor or other popular topics out there. Okay, from Raj. Typically, you/CMU provided the robot kit along with training for on-campus site. You still plan to do so with the proposed V5 training fees include the costs. So, Raj, thanks for your question about training. If you come to our training in Pittsburgh, we will have kits built and ready to teach. If you are doing online training, then we ask that you have your own kits. CMU is not a reseller of the VEX kits, so we're not able to bundle them in with the pricing or things like that. But if you do come to Pittsburgh, we'll have them here for you, ready for use. But for online training, you will want to have them. Okay, from 41091A, is it possible to factory reset the V5 equipment? And if there is a way, what should be done to do so? Thank you. So there's different things depending on exactly what you mean. On the V5 brain itself, there's a settings menu. So if you have the V5 brain on, go to the home screen, go to settings, and there's options to reset the V5 to factory default. There's a setting to delete all of the programs. So you can do both of those. Um, if you are wanting to download firmware and things like that, I believe VEX is coming out with a utility for some of those kinds of things outside of just updating the firmware within VEX Coding Studio. All right, and then there's a helpful comment from 56E2 that again, depending on what you were looking for, if you're looking to do, a hard reset on the device to power cycle it, there is a small hole on the bottom of the controller. Stick a VEX axle in there, that should work. Thanks for that tip, 56E. All right. Well, the questions have slowed down. As always, feel free to post your questions either on the VEX forum or we'll be checking the YouTube comments. Happy to answer things inside of there. And then we will see you again or talk to you again in 2 weeks for the fourth session. And again, that one is around uh, trans. Translating between ROBOTC graphical and ModKit blocks. Thanks, everyone.